Hi, this problem is about the moment of a force in 3D space about a point O. So in this problem we have a force vector F equals force vector F, which is given as a Cartesian vector 2j plus 1k kilonewton. And we have a moment vector here, and that's about point O. That is given as 4i plus 5j minus 14k kilonewton meter. So that's kilonewton, and that vector kilonewton meter units. So if the force acts at a point having an x-coordinate x equals 1, so that is that distance x equals 1 meter, and determine the y and z coordinates. So y and z coordinate, so that's the question. So as we know, moment of force about a point is calculated by multiplying a position vector r times the force vector. So that specific position vector can be any vector. That can be any vector, right? Any vector that would start from point O and lead to any point lying on the line of action of force vector F. So that's the line of action of the force vector. So if you remember, any vector can be used for this purpose. So that can be used. So that can be another vector, right? But for this specific question, since we are trying to find the coordinates z and y, it is better to use a vector OP. So because coordinates of P is x, y, z, so x is 1, y we don't know y, and we don't know z, so we are trying to find y and we're trying to find z. So what are these? That's why choosing the position vector to be OP makes sense. Okay, right. So we continue with that. So if you substitute this given moment vector, so 4i plus 5j minus 14k, so that's the moment vector, moment O vector, and that is equal to, we know that this is the determinant of a matrix, and that matrix includes I, j, k here, and then the second row includes the components, x, y, z components of the position vector. So the position vector components would be 1 minus 0, 1, y minus 0, so y, and z minus 0, z. Okay? And the third row, includes the components of the force vector. So x component is 6, y component is minus 2, and z component is 1. So I substitute here these values. Okay, and from here I get I'm not going into details of this calculation, but you should remember, like, for calculating this, you like, for example, for the y component of the resulting vector, what you do is, for example, you delete this row and this column and this row, okay, and you multiply in this direction y times 1, and then go up, and then minus z times minus 2. Okay, so the I component would be y minus 2 times z, and that will be equal to I y plus 2z. Okay, so and the rest would be in a similar fashion. So you end up with like the I component of this side will be equal to the I component of the other side. So 4 will be equal to, so this value, this expression y plus 2z. Okay, and then we will have for the j component, which is 5, so 5 will be equal to, so if you delete this one and that one, you're going to end up with I minus 6z, but that, if you remember, that should be minus j, so we end up with minus 1 plus 6z, okay? 6z. And for the z component, it's minus 14. That will be equal to, so deleting this row, this column, and that row, you end up with these 4 here, and that's minus 2 minus 6y. So that's minus 2 minus 6y. Okay, and then we have 3 unknowns. Sorry, we have 2 unknowns here and 3 equations. So from here we find y equals 2 meters and z equals 1 meter. Okay, so and that's the solution of this problem.